This is the final section in our Chapter 1 lessons, and this talks about the property of real numbers. So this kind of ties everything that we've done back together. So we're going to just jump right on in with the properties. The first property is the commutative property. I always want to say commutative property, but there's no N in the word. So just please overlook me if I mispronounce the word. But in this property, it says it is good for addition and multiplication. Notice that it is not good for subtraction and division. I will show you why in just a moment. So if you notice, commutative property for addition says A plus B equals to B plus A. So that would be an example, 4 plus 2 equals to 2 plus 4. Both sides are 6. So it doesn't really matter if you say 4 plus 2 or 2 plus 4. You could even go as far as to say 4 plus negative 2, as long as you said negative 2 plus 4, both sides are still equal to positive 2. Now, so it applies with negatives, but what does not work, and I'm going to show you subtraction since addition and subtraction are pretty similar. What does not work is 4 minus 2 definitely does not equal to 2 minus 4. This side, the left side, is positive 2 when the right side is negative 2. So the commutative property does not work for subtraction, and that is why. Now, multiplication. We can do the same thing. I can take 4 times 2 and equal it to 2 times 4. Notice that I just changed the order. Both sides still 8. I can do 4 times negative 2, or I could do negative 2 times 4, and both sides would still be negative 8. Now, the division property does not work that way, and I'll do that over here on the left. 4 divided by 2 definitely does not equal to 2 divided by 4. On the left, I get 2, but on the right, I get 1/2, and those two numbers are not equal. So when you are applying these property of real numbers, remember they only work if you are adding or multiplying. They do not work for subtraction or division. So this says to use the commutative property to rewrite each expression. So negative m times x is just negative mx. A negative times a positive is still a positive. But if you were to rewrite it, you should be saying x times negative mx. Now, if you are rewriting number 2, you cannot rewrite a subtraction problem. But if you recall from our lesson on subtraction, I can rewrite that as a plus the opposite of 17, and then I can switch it to negative 17 plus a. On number 3, I'm simply going to flip the numbers. So I would have negative 52 times b. And in the last example, I would have 12z plus 5a. Now, the associative property, I call the regroup property. Notice here again, it's only for addition and only for multiplication. These do not work for subtraction or division. So the first thing I want to point out for both associative properties, notice that I have ABC on this side and I also have ABC. The order of the ABC does not change. What changes is the group. The parentheses slides over. So in the first part on the left-hand side, A and B are grouped together, but when you slide across the equal sign, B and C are grouped together, and that is okay. But notice that the numbers do not change. So if I had 2 plus 3 plus 4, I could rewrite that as 2 and then group the 3 and the 4 together. I still get the same outcome. On the left, I get 6 plus 4, which is 10, and on the right, I'm sorry, I do not get 6. Wow, your teacher has lost her mind. 2 plus 3 is 5. 5 plus 4 is 9. And then I get 2 plus 7, and that is still 9. So I can slide the group, but notice the order. It is still 2, 3, 4 on the left and 2, 3, 4 on the right. The only thing that moved was the grouping symbol. Same thing for multiplication. I can group 2 times 3 times 4, or I can say 2 times 3 times 4 in a group. Both of these will equal the same thing. 2 times 3 is 6, times 4 is 24, and 3 times 2 is 12, and 2 times 12 is also 24. So notice that I still have the same order, 2, 3, 4 on the left and 2, 3, 4 on the right. The only difference is the parentheses moved. So in 5, 6, and 7, it is asking us to use the associative property for either addition or multiplication to rewrite. So that means we're going to move the parentheses. Now, since the parentheses on number 5 are in the back and it's grouping the 13 and the 4 or the A together, I'm going to slide them forward this time. So I'm going to keep the same order, -4 times 13 times A. In number 6, if you notice 4B and 13 are grouped together, and then we're adding the -8, so I'm going to slide the parentheses, keep the same order, 4B plus 13 plus -8. The only difference is I'm going to move the grouping symbol. My order did not change, my groups moved. My grouping symbols moved. Here, I'm going to move the grouping symbols forward, so I should have -27 times -2, and all that grouped together with X on the back. Okay, now I can simplify the expression. In the second example, actually in the first example, I can now multiply -4 and 13 and get -52A. So that's the simplified version. In the second example, I can add 13 and -8. I get 4B plus 5. That's the simplified answer. You cannot add 4B with 5 because they are not like terms. And then in the third example, I can multiply the -27 and the -2 and get positive 54x. That would be the simplified expression. Now, the identity and inverse properties. Notice again, there is a typo. This should be multiplication. That you can only use the identity and inverse properties for addition and multiplication, just like you can all the others. No division, no subtraction. So this identity property for addition says anything plus 0 is that number. So 10 plus 0 is the same thing as 0 plus 10, which is 10. The multiplication property says 10 times 1 is the same as 1 times 10, which is 10. Now, the inverse property says we're going to add the opposite. So 10 plus -10 would equal -10 plus 10, which equals to 0. That is the inverse property for addition. Now, if you notice, the inverse property for multiplication is I'll take 10 and multiply by 1 over 10, or I can take 1 over 10 and multiply by its reciprocal, and the outcome is always 1. So you have to be very, very careful when you are using these. The identity properties equal to A, and the inverse properties either equal to 0 or 1. Okay, 0 is said to be the additive identity and 1 is the multiplicative identity. So be very, very careful with those. Now, you may recall distributing property, and we're going to go over this again because you are going to use this from this point forward throughout the whole class. It'll just keep popping up over and over and over again. So if A, B, and C are real numbers, then A times the group B plus C becomes A times B and A times C. So what you're doing is you're taking this front number and you're multiplying it by both of the numbers inside the parentheses. Okay, now it doesn't matter if the number is in the front or if you're multiplying from the back end. You can distribute from the front just as easily as you could distribute from the back. Most of the time, this is what you see. It's very rare that you see this, but it does happen, and sometimes it confuses people. So in this particular number 8, we are using the distributive property to rewrite each expression. So I'm going to take my number out in front, which is 5, and I'm going to multiply it by the A and the negative 3. So 5 times A is 5A, and 5 times negative 3 is negative 15. I cannot add 5A and negative 15 together, so I leave that alone. Here, I'm going to take 6 and I'm going to distribute it. So that would be negative 54x. That would be positive 48y. And then negative 72z. In number 10, I am distributing a negative. That's actually a negative 1. So a negative times a negative becomes a positive. A negative times a positive becomes a negative. So basically, when you have that negative 1 out in front, you change all the signs that are in the groups behind it. Here, I'm going to multiply negative 3/4 times 2x and negative 3/4 times 16. So I should be thinking negative 3/4 times 2x. That's going to give me 2 goes into 4 2 times. So that gives me negative 3 over 2x. And then I'm going to multiply negative 3 over 4 times negative 16 over 1. 4 goes into 16 4 times. A negative times a negative is a positive. And then 3 times 4 is 12. So this would be the final answer. You cannot add the negative 3 over 2x to the 12 because they are not like terms. Now we are going to talk about terms in this next section. And the term is a constant or the product or quotient of constants and variables. So 5x to the third is a variable term. 5 is the coefficient of the term 5x to the third. 12 is a constant term. The reason it is a constant term is because it has no variable attached to it. So an algebraic expression is the sum of one or more terms. So I could take 5x to the third and I could add 12 to it. That becomes an algebra expression. All right, like terms have the same variables and the corresponding variables are raised to the same power. So x to the third and 3x to the third are like terms because x to the third is in both groups. Now notice that a term, remember, is a product. So 3 times x to the third makes it a term. All right. Now, it asks which pair are like terms. This is a pair of like terms because they have the same variable and that variable has the same exponent. They both have just b. It doesn't matter about the 4 and the 2/3, not yet, but the fact that they are both variable b and only b means that they are like terms. These two are not like terms because I have an x here, but I have an x squared here. X does not equal to x squared. Y squared does not equal to y. So my variables do not have the same exact exponents. And in the third one, this is no, because 3y has the variable y, and 3 does not have a variable at all. So in this problem, it was the exponents that made these problems or these terms not like. And here it was the fact that one had a variable and the other did not. Okay, now in order to add or subtract like terms, once you decide they are like, the example 5y plus 6y, since they are like terms, we're going to add the coefficients 5 and 6 and get 11y. Here we have 7z minus 10z. They are like terms, so what you should be thinking is 7 minus 10z. You look at the coefficients, the numbers out in front, and then you subtract them and you get negative 3z. So we're going to do several of those problems. So in this problem, I can add my 6 plus my 14 because they both have the same exact variable x. So that ends up being 20x as a final and total answer. Now, in number 16, I only have 2 terms that are like. I have 3 terms, negative 0.3a and negative 1.5a. So what I am going to think is I need to add negative 0.3 plus negative 1.5a and then keep the 2b. I can't change the 2b because I don't have another term in this problem with just a b as its variable. So when I add this together, I get negative 1.8a plus 2b. That would be my final answer. You cannot add up a's and b's together. In number 17, I have 2 sets of like terms. The first set of like terms, I have the constant 12 and I have the constant negative 8. So I'm going to add 12 and negative 8 and I get 4. The second group are the x squares. So I should be thinking negative 6 plus 1. There is an understood 1 in front of that x square, and that gives me negative 5x squared. Now, you can write your answer this way, or you can put negative 5x squared in front of the positive 4. As long as the negative stays with the 5x squared and the positive stays with the 4, you can rewrite it that way. Now, in number 18, we have a couple of like terms. We have x, and then we have the y's. So I should be thinking 1/3 plus 2/3 x, which is 3 over 3x, which is just 1x. You normally don't put a 1 if a variable does not have a number in front. It is considered to be a 1. And then for the second, the y's, I should be thinking negative 2 plus 1/4 y. I need a common denominator, so that would be negative 8 over 4 plus 1/4, which is negative 7 over 4. So I end up with negative 7/4 y as my final answer for number 18. Now, we're going to take this just a little bit further, and we're going to do a few more examples. I'm not going to go through each and every one of these examples. I don't think it's needed, but I will go through at least 3 of these. So I'm going to go down and I'm going to do 20, 22, and I will do 24. So the first thing I need to do is clear the parentheses by distributing. So when I clear the parentheses, I'm going to take positive 12 and I'm going to multiply throughout that parenthesis. So negative 23 does not change. Positive 12 times negative 3 is negative 36x. Positive 12 times positive 5 is positive 60. Now, I have like terms, negative 23 and 60. They are constant values, so I can add those together. So negative 36x does not get changed, but negative 23 plus 60 becomes 37. That would be my final answer for number 20. Number 22, I have 2 sets of parentheses, so I'm going to have to distribute twice. In the first one, I'm going to take the 3 into the first group, so 3 times negative 5 is negative 15y. 3 times 2 is 6. Then I'm going to take 7 into the second parentheses. So that is 7y minus 28. I can add up my y's. So I should be thinking negative 15 plus 7y, which gives me negative 8y. And then I can add my constant values together. So I should think 6 minus 28. And that gives me negative 22. So my final outcome here is negative 8y minus 22. Now, I know I said I was going to do number 24, but I changed my mind because I'm sure most of you would rather see 23 since it has fractions. So we're going to do number 23 as opposed to number 24. Now, if you would like me to do number 24 when we have our class meeting, you can ask me and I will pull it up and I will be more than happy to work through number 24 for you. So here I'm going to distribute the 1/8. So I should be thinking 1 over 8 times 16x. I can put that over 1 and I can cross cancel, and that gives me 2x. Then I'm going to take 1 over 8 and multiply it by 24. If I put 24 over 1, 8 goes into 24 3 times, so that gives me plus 3. Now, I'm going to take negative 3/4 and distribute it. So I have negative 3/4 times 2x. If I put 2x over 1, 2 goes into 4 twice. So that gives me negative 3 over 2x. And if I take negative 3 over 4 and multiply by positive 12, if I put 12 over 1, 4 goes into 12 3 times. Negative 3 times 3 is negative 9. So now I have like terms. I have 2x and negative 3 over 2. So 2 minus 3 over 2, I need a common denominator. So that would be 4 over 2 minus 3 over 2, which is 1/2. So that would be 1/2 x. And then I take my 3 and my negative 9, add those together for a total of negative 6. So 1/2 x minus 6 is your final answer for number 23. If you have any questions about any of this, please make sure you let me know.